Good afternoon, everyone. This is lecture number 1, and the new topic is WPE, work for energy. I guess you know something about this topic, yes or no? Do we know anything about this topic, work for energy?
Yes, sir.
What do we know about this topic? Tell me. Hmm? The first thing that we are going to study in this topic is work. What do you know about work? What do we know about work?
Product of force and displacements.
What type of quantity is force? And what type of quantity is displacement? What type of quantity is displacement? Say,
Vector, sir.
when you say product of force and displacement, what product are we talking about?
Cross product.
Say it completely. If you say just the product, it will not make any sense. So, if we just talk about work, work is said to be done when a force produces a displacement in the body on which it acts in any direction except perpendicular to the direction of force, because when the force is applied and the body is moving perpendicular, in physics we don't call it as work done. Do we understand this?
Yes, sir.
I hope you are noting it down. So there are two things that are necessary for work to be done when we say work is done in physics. The first thing is there must be a force applied on the body and there must be a displacement of the body. Do we understand this? Yes or no? So that is when we say work is done by a body. If we have a force F and we displace the body by a small displacement dr, the small amount of work dw is F dot dr. This is how a small amount of work delta W or dw is defined. To find out the total amount of work, which I write it as delta W, it is the integral of F dot dr, or I can write it as integral of F into dr into cos theta, where what is theta? What is theta? Theta is the angle between
Force and displacement.
force and displacement. Theta is the angle between force and displacement. What type of quantity is work done?
Vector, sir. Sorry, dot product. Sorry, it's a scalar, sir. Dot product. Sorry, sir.
Work done is a scalar quantity. Beta, please don't say this vector quantity. It breaks my heart. It is a scalar quantity. It's a basic number. So this number can be positive. This number can be negative. This number can be 0. What decides whether this is a positive or a negative number? Because it is a number. What thing decides whether it is positive or negative? When do we say work done is positive? Which factor decides whether the work done by a force is positive or negative? Yes.
If the displacement in the direction of force, then the work is said to be positive. And if displacement is opposite to the direction of force, then it is said to be negative.
So what decides whether it is positive work or negative work is the value of cos theta. If cos theta is positive, work done is positive. If cos theta is positive, that means theta is acute. This is better way of saying. When the force and displacement are in the same direction, they may not be in the same direction, but if there is an acute angle between them, work done will be positive. When will it be negative? When cos theta is negative, that means theta is obtuse angle more than 90. whenever angle between force and displacement is more than 90, work done by the force is 0. When will work done by a force equal to 0, even if there is force and displacement? When cos theta is 0, that means theta is 90 degrees. That means when force is perpendicular to displacement, even though it might do some work, in physics that work done is taken as 0. Do we understand this?
Yes, sir.
So work done by a force is positive or negative depending on the angle. Now, when we talk about work done by a force, we can study it under two headings. We can first study it in the heading of work done by a constant force. Work done by a constant force. If the force is constant, what do you mean by constant force? It must be constant in magnitude as well as in direction. Do we understand this? It must remain same. It must remain same in magnitude and it must remain same in direction. Do we understand this? That is what we say, work done by a constant force. Now, if there is a constant force, we can write work done, which is nothing but integral of F dot dr, or it is integral of F into dr into cos theta. If everything remains same, F and theta are same, angle and the magnitude of force is same, you can write it as F cos theta into integral of dr into the integral of dr will give you the displacement or delta r. So you can write this as F dot delta r, or you can write it as F into delta r into cos theta. Do we understand this? So this is how you can find out the work done by a constant force. Work done by a constant force is F dot dr or F dot s if you call s as your displacement. Do we understand this? Yes or no? Huh? Do we understand this? What we have written?
Yes, sir.
Okay. Now, if you have more than one force acting on a body, and if you are supposed to find out the work done by the total work done by all the forces, what do you do? How do you find out the work done by more than one forces? Yes, if you have more than one force acting on a body, in most of the questions that we are going to do, more than one force is going to work on the body, is going to act on the body. How do you find out the net work done in that case? So the best way of doing it is, if you have to find out work done by multiple forces, work done by multiple forces, how do you find it out? Instead of doing this in this way, it is better to do it in this way. What is this way? You find out the work done by the first force, you find out the work done by the second force, third force, and so on, and you add them all together. Do we understand this or not?
Yes, sir.
Please remember this. If you have to find out work done by a number of forces, you find out the work done by each force and then simply add them. I hope everyone is noting this down. Only note the important points that I'm highlighting. Do not write everything, just write that important thing that I've highlighted. Do we understand this? Don't have to write everything. You just have to write what and how you are going to do this. This is how you are going to do this. Just write this. not the other things. Do we remember? Do we understand this?
Yes, sir.
Okay. Have you done this?
Done, sir.
Then there are some important points that you must remember about work done. I have written work done as you can see. The symbol that I've used for work done is delta W and not simply W. I have used this word, this letter delta. Why I've used this letter delta? I only use delta when I'm talking about change or difference, or I'm talking about something which is calculated over an interval of time. That is the first point that you must remember about work done. Work done is always defined for an interval. There is nothing called instantaneous work. There is no term like instantaneous work. That means what is your work done now? There is no term like this. You only talk about work done between two instants of time, between 2 points. Do we understand this? First, understand the points and then note them down. Do you understand this point number one? Work done is
Yes, sir.
always over an interval. So I write it as delta W. Work done for a particular displacement is independent of the type of the motion. Whether the body moves with constant velocity, constant acceleration, or retardation, it is F dot dr. Whatever is the force, dot with dr, it does not depend on time. It does not depend on the motion. Do we understand this?
Yes, sir.
Third point is about time. It is independent of time. If I go from my
Dependent.
home to my workplace, work done by friction does not depend on how much time I sit or how much time I walk. It only depends on how much I move. Yes or no?
Yes, sir.
When more than one forces are acting, work done by one force is independent of the work done by other forces. That is why to find out the total work done, what do? We find out the work done by the first force, we find out the work done by the second force, because these two work does not depend on each other. Work done by gravity will not depend on work done by friction. Work done by friction will not depend on the work done by the spring force. Do we understand this?
Yes, sir.
Now remember, force is independent from reference frame, but displacement depends on frame. Therefore, work done by the force will be different in different reference frame. If I am sitting in a bus and I don't see anything moving, work done by anything would be zero. But if a person who is sitting on ground and he sees something kept on the bus, that bus is moving, so that something is moving, so he will see work done, but I will not see any work done. Why? Because work done depends on reference frame.
Reference frame.
Now when some work is done, there is a change in kinetic energy or change in shape. Change in shape we'll deal in the chapter of elasticity. Here we'll deal with change in kinetic energy. Whenever work is done on a body, its kinetic energy changes. We will see that theorem that is known as work energy theorem. Right now, work done leads to change in kinetic energy. And who does work? Work is done by the agent who is applying that force. Do we understand all these points?
Yes,
Some
sir.
of these points may come as questions in your examination. I'll note them down. We might be using these points in our discussion further. I'll give you 2 minutes to note it. अभी तो नहा रही हो तुम जा रही हो क्या वहाँ पे अभी निकल रही हो हाँ तो नहीं ना गेट बंद कर दिया है Have you noted this down, bacha?
Done, sir.
Okay. Then let us concentrate on work done by constant forces first. Now remember, what are the forces that are going to come in this chapter whose work done we have to find out. What are forces? What all forces will come in this chapter whose work done we need to find out? Tell me. In this particular chapter, what all forces will come whose work done we need to find out? These are the same forces that we studied in the previous chapter, beta. Tell me.
Yes, sir.
What, sir?
Gravitational force,
Gravitational force,
frictional force.
frictional force, normal force, and so
Yes,
on.
sir.
Okay, let us take this example of a block which is kept on ground. The mass of the block, let us say, is 10 kg. The value of frictional coefficient is 0.2, and I apply a force of 50 newtons on this, and let us say I move this block 6 meters. I move this block 6 meters. Can you tell me what is the work done by G? G का मतलब क्या है? What do you mean by G?
Zero, sir. Work done by gravity is zero.
Work done by normal reaction, work done by F, frictional force, and work done by the 50 Newton force. Can you tell me all these answers? I'll give you 2 minutes to do this.
Okay.
Let me make it a bit more thing. Let me apply this force not like this. Let me apply this like this. 50 newtons at an angle of 37 degrees. Let's see if you can do this. I hope you can see this.
Yes, sir.
Okay, now do it. Why is it taking so long? Is it such a difficult question to answer? Huh?
Sir, wait a minute.
Okay.
Yes, sir, it's done. Hello, sir.
Okay, so how do we do this? First of all, let us draw the free body diagram. The weight is 100 newtons downwards. Normal reaction is N. This force is 50 newtons. I can also resolve it into two components. Yes or no? I can resolve this into 50 cos 30. Cos 37. Cos 37 is 4 by 5. So this becomes 40 newtons. Yes or no?
Yes, sir.
And this becomes 30 newtons. Yes or no?
Yes, sir.
Okay, now let us find out the work done by gravity. What will be the work done by gravity? Look at the gravitational
0, sir.
force. It is downwards and the displacement is in the forward direction. The angle between them is 90. So the
It
work
is
done
0.
is 0. Do we understand this?
Yes, sir.
Let us talk about the work done by the normal reaction. What is the value of
0,
normal
sir.
reaction? The
0.
value of normal reaction is 70 newtons. Yes or no?
Yes, sir.
But whatever it happens, the angle between normal reaction and this, in fact, in all the cases, the work done by normal reaction in most of the cases, if the body is moving on a plane, the work done by normal reaction in that case will always come out to be 0. Yes or no?
Yes, sir.
Let us try to find out the work done by friction. To find out the work done by friction, we have to find out the frictional force. So how much is the frictional force? If I draw the frictional force, it will be backward, yes or no?
Yes, sir.
And it will be kinetic friction, yes or no?
Yes, sir.
What is the value of friction force? The normal reaction is how much? 70 newtons, yes
70.
or no?
Yes, sir.
70 multiplied by 0.2, it is 14 newtons, yes or no?
Yes, sir.
14 newtons is the frictional force. It is backwards, body is moving forward, so angle is 180 degrees, yes or no?
Yes, sir.
So work done by this will be negative. F into displacement into cos theta. F is how much? 14. How much is the displacement?
6 meters.
14 into 6 multiplied by cos of 180. Do we understand this? Yes or no?
Yes, sir.
So it will be equal to minus
Minus
14 into 6
16.
joules. Yes or no?
Yes, sir.
Okay. Now let us talk about work done by the force which is applied. Now there are two ways to find out this work done. If you can take this as the force, then this is the displacement and this is the angle between force and displacement. Yes or no?
Yes, sir.
Or you can take the component of the force 40 newtons in the direction of displacement and then find the work done by that force, because this component will not do any work. Do we understand this?
Yes, sir.
So whatever way you do it, you multiply 40 by 6 or you multiply 50 by 6 multiplied by cos of 37. In all the cases, you will get the same answer. What will be the work done by this force of 50 newtons?
240.
Plus or minus?
Plus, sir.
Do we understand this? Yes or no? No or yes?
Yes, sir.
Everyone understands this?
Yes, sir.
I need raise hands. I don't see raise hands from everyone. Do we understand this, girls, boys, everyone? Okay. Now remember, there is something that you must remember. Some points about work done by friction. Some important points about work done by friction. Now to find out the work done by friction, you multiply the frictional force F by the distance of the body and not by the displacement, because if I start from A, I move to B and I come back to A, the displacement would be 0, But will the work done by friction be 0?
No, sir.
So remember, for work done by friction, to be careful, find out the frictional force and see how much it has moved. Find out the distance. Even if it is moving in a zigzag path, find out the distance, multiply it by the frictional force. That is how you will get the work done by the frictional force. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this? Now there are two types of friction: kinetic friction and static friction.
Static friction.
Remember, when the friction is static in nature, now remember, this friction is a action reaction force. So if friction is doing positive work on one body, on the other body it would be doing
Negative work.
negative work. So it's not necessary that friction always does negative work. Friction can also do
Positive work.
positive work. Do we understand this?
Yes, sir.
Friction can also do
Positive work.
positive work, because friction will be acting in a direction which is opposite to the direction of relative motion. Friction can also do positive work on one body, it can do negative work, and on the other body it can do.
Positive work.
Will you remember this?
Yes, sir.
Okay, this is the work done by forces. Now sometimes this forces and the displacement is given in the vector form. So we can write work done we can write the work done in a different way as well. Now remember, we are talking about work done by a constant force. You can also write this in a different way. Now work done by a constant force. For example, your force is given like this in vector form: Fxi plus Fyj plus Fzk. So this force is a three-dimensional force, and the displacement of the particle is given as xi plus yj plus zk. Now remember, this force is a constant force. If I have to find out the work done by this force, what I will do, I will take the dot product of force with displacement. Do we understand this? Now when I take the dot product of force with displacement, I will dot this with this, fx with x. When I dot fx with y, the dot product will be 0. Yes or no?
Yes, sir.
So when I dot, only these terms will be left, and the final answer would be fx dx. Sorry, instead of writing dx, I should write it as fx into x plus fy into y plus fz into z. Do we understand this?
Yes, sir.
So if the force is given in the form of a vector, this is how you can find out the work done by that force. Do we understand this? Yes or no?
Yes, sir.
Okay, then we can solve a problem based on this. A force F is equal to 2I minus 3J plus 4K displaces a body from 1 to 3 to -2, 1, 4. Find the work done. These types of questions are coming these days. They are pretty simple. I'll give you 1 minute, 2 minutes to solve this out.
Yes, sir. It's done.
Everyone got the answer? Let me give everyone time.
Sir, 2 joules, sir.
How are we supposed to get this answer? Let us first find the displacement. How do I find the displacement vector? This is the initial position and this is the final position. We all understand this, yes or no?
Yes, sir.
Final minus initial will be your displacement. Final is 2, initial is 1. So what is the displacement in x?
Minus 3
Minus,
I.
minus 2
Minus 3 I. Minus 2 I. Minus I.
I. So it becomes minus 3I. 1 here, 2 here. 1 minus 2 becomes
Minus 1J.
minus 1J. 4
Plus 1.
here, 3 here. 4 minus 3 becomes
Plus 1K.
plus 1K. That is your displacement. Your force is 2I minus 3J plus 4K. Yes or no? You can take the dot product and that will be your work done. How do you take the dot product? This is multiplied by this is multiplied by this, and this is multiplied by this. Minus 3 multiplied by 2 is minus 6. Minus 1 multiplied by, oops, not, sorry. Do you see it now? Okay. Minus 3 multiplied by 2 is minus 6. Minus 1 multiplied by minus 3 is plus 3.
Plus 4.
And 1 multiplied by 4 is plus 4.
It's 1.
You said 2. Now you have come to 1. Do we understand how this is done?
Yes, sir.
Everyone, what I have done here is I first found out the displacement and I just then taken the dot product of force with displacement. Anyone got this? Now, if this force would have been not constant, but if this force would have been variable, so how would you have done the work done by variable force? How would you find out the work done by a variable force? Same thing you will do. Your force will be given as Fx I plus Fyj plus Fzk. Now you can take small displacement del dr as dxi plus dyj plus dzk. Do we understand this?
Yes, sir.
Then I take the dot product that will give me small amount of work dw fx dx plus fy dy plus fz dz. To find out the total work, I will take integration. You know how to integrate? So I will integrate from x1 to x2, y1 to y2, and z1 to z2. Do we understand this?
Yes, sir.
Yes or no? No, yes?
Yes, sir.
Have you noted it down, everyone, bacha?
Yes, sir.
Then you have this problem. Please solve it. An object is displaced from the position vector 2i plus 3j to 4j plus 6k using a force 3x square I plus 2yj. What is the work done by this force? I'll give you 2 minutes to do this. Yes, bacha, any answers? Shall I do it for you?
Sir, we need some time.
Okay, okay.
Yes, sir, it's done.
Everyone has got the answers? What is the answer? Tell me, bacha.
21 joules, sir.
21 joules. Let me check what answer I have. Mm, 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 mm. 83 joules is the answer, my dear friends. 83 joules. You are getting 21 joules. That is not the correct answer. Would you like to try again or shall I do it?
Yes, sir, you can do it.
Given up so easily? Okay. So how do I get the answer? To find out the work done, I do the integral of fx dx plus integral of fy dy plus integral of fz dz. That's it. You need to do it that one. What is fx? Fx and fy are given. Fz is 0. So this term does not come. Do we understand this? Yes or no?
Yes, sir.
Fx, how much is fx? It is 3x square. So it is 3x square dx ka integral. From where to where is x varying? Here x is how much here? Here x is 2.
0 to 2, sir.
Yes, beta?
2 to 0, sir.
Okay, yeah, that should be correct. 2 to 0 plus integral of fy. Fy is how much? 2y. 2y dy. Integral from where to where y is varying. Look at this.
4 to 3, sir.
3
3
to
to 4,
4,
sir.
beta. 3 to 4, beta. Please be careful. 3 to 4. That is the work done. So x square. Sorry, it is 3x square dx. So it will be x cube by 3. So it is simply integral of, it will be x cube varying from 2 to 0. Yes or no? Plus 2y square by 2. 2 and 2 will cancel. So y square from 3 to 4. You put the values and you get the answers. What is the answer you are getting? 21?
Yes, sir.
Then that is correct. So it is 0 minus 8 plus 4 square is 16. 16 minus 9. How are you getting 21, bacha? I'm getting this. Am I getting it wrong? I don't think so. Do you know how to integrate? Yes or no?
Yes, sir.
So that is the answer. I think I'm getting -1, and that is the answer. minus 1 joules. Do we understand how this is done? Do we understand how this is done?
Yes, sir.
One more question that you will try as homework and tell me the answer. You can do it easily. A force xi plus 2yj is applied on a particle. The particle is moved from 1, 2 to 0, 1. What is the work done by the force? I hope you can do this as homework. Yes or no? Please note it down. Do it as homework. Tell me the answer in the next class. Okay? So I think we have done a good number of things in this class. I needed to complete one more point, but I just could not do it. Anyways, we will do it in the next class. I'll see you in the next class. We'll continue with work done. One or two more things we'll do. Then we will move on to energy, and then we'll move on to work energy theorem, which is the basis of this chapter. So see you in the next class. If you have any doubts, come up to me and ask. Else, bye-bye. Take care. Have you noted down this question, bacha, everyone? Okay, I'll send you some sheets for practice by tomorrow, by today, and I hope you get it by tomorrow. Take care. Have a nice day, beta. Bye-bye.